touchless sensor. A touchless sensor consists of two groups of electrodes on both sides of the dielectric frame. There is a transmitting electrode connected to the voltage source, and there are receiving electrodes. Receiving electrodes' electric potential depends on the presence of the human finger. Finger is simulated as a conducting body with a zero electric potential. In fact, it is a Hoover sensor. There is no need to touch it. The sensor detects the human finger some distance away from the sensor surface. For simplicity, we will approximate the finger shape with a cylinder placed perpendicular to the surface of the sensor. So this three-dimensional model could be constructed through extrusion. Let's start QuickField now and take a look how it could be done. In QuickField, I create a new problem. Sensor. Next. Problem type is electrostatics, length units are millimeters, and the model class is three-dimensional extrusion. Finish. The problem is created, and here is the sketch editor window. In a three-dimensional extrusion model, I should draw a two-dimensional sketch and assign heights to objects. Here I will insert a rectangle with the dimensions 280 by 250 millimeters. Insert. And another rectangle with the dimensions 230 by 180 millimeters. Close, zoom to fit. This way I have constructed the dielectric board. Now I should assign levels. The dielectric board thickness is 1 millimeter, so I assign two levels, 0 and 1 millimeter. Build the finite element mesh and toggle two-dimensional, three-dimensional view. So you see the board is constructed. Return to the sketch view, switch to insert mode and draw some lines here. This would be the traces. Okay, switch to select objects mode and select and remove unnecessary parts. At the bottom and here at the top. Okay, again build the finite element mesh and switch to three-dimensional view. Here in the three-dimensional view I should assign labels. Click to select and the face is selected. To select the body I should click the selected face again. Now the body is selected, or another way to select multiple bodies is to use the rubber band. This way I have selected faces, bodies, edges and vertices. Now for the bodies I assign label dielectric. At this side of the dielectric board we have receiving electrodes. Rx left, Rx right, Rx top, and Rx bottom. And on the other side we have a transmitting electrode. Front side, back side, and the transmitting electrode is that large. To select multiple objects at the same time, hold the control button pressed. All this is a transmitting electrode, TX. Okay. Now let's provide physical properties for these labels. Double-click the label name. Dielectric permittivity of the board is 4.3. Transmitting electrode electric potential is plus 1 volt. And the receiving electrodes are floating. The electric potential is unknown. I should calculate the electric potential. Floating conductor. Now I should add a finger to this model. Switch back to the sketch view and draw a finger. This would be a circle with a diameter of 10 millimeters. Insert. Close. The finger is located some distance away from the sensor surface. So click here to select and assign levels 50 millimeters away, and the finger length is 100 millimeters, so another level is 150. Build the fine element mesh, toggle to three-dimensional view, and here is the finger. It is approximated as a cylinder. Select. The finger is a conducting body, so there is no need to assign label to the body. There is no electric field inside conductors. Instead, I'm going to assign label to the faces. Finger. And the finger electric potential is 0. Okay. Now I'm going to move the finger away from the central position. Select the finger, hold the Alt button pressed and drag. Okay. Build the finite element mesh, toggle to three-dimensional view. Now I have a finger here. Rx bottom, Rx left, finger. Okay. The last object I should add to the model is the air. So switch back to the sketch view, zoom out, switch to insert mode, and draw the air block boundary. Oh, let's move it to the right. Okay. Now let's assign levels to the air block. Select everything, because above and below the sensor we have the air too. So I select everything and assign levels minus 100 millimeter and plus 200 millimeters. Build the finite element mesh, toggle to three-dimensional view. I better add more air on top and on bottom. So switch back to the sketch view, select everything. Instead of 200, I will type in 400, and instead of minus 100, I will type in minus 300. Toggle to three-dimensional view. Now that looks better. And we should assign label to the air block. Click and the face is selected, click again and the block is selected, and this is air. Dielectric permittivity of the air is 1. Now hide this block. You see we have sketch printed on all levels, so I should assign label to these blocks as well. Air, air. Now let's hide air blocks. Zoom in. Dielectric and finger. Now the geometry model is ready. Before I can start the analysis, I should build the finite element mesh. You can do it in 3 steps. First you build the mesh on edges, then you build the mesh on faces, and the last you build the mesh in volumes. The volume mesh was constructed and I have forgot to assign label to the external boundaries. Unhide all. Zoom to fit. Far away from the sensor, the electric field fades to 0. So at these boundaries, the electric potential will be 0. I assign label external. And I should select the bottom boundary, external, and these sides external. And for external faces, I specify 0 electric potential. Now everything is ready. Save all problem files and solve the problem. The problem has been solved. Let's take a look at the results. Here you can see the electric potential distribution on the air block faces. And it is 0 as I have specified. Let's hide the air block. Hide. The finger is grounded with 0 electric potential. Here is the transmitting electrode with electric potential of 1 volt. And on the other side are receiving electrodes. And their potential is almost 0. Let's adjust the view. And I will use the integral calculator. Click to select and find the average surface potential. Let's put this value in the table. Rx left, right, top, bottom. Top is this value. Right, this value. Bottom, this value. And let's find the difference between the transmitting and receiving electrode's electric potential. Transmitting electrode electric potential is 1, and the difference is these values. Now, if you take a look at this data, you will see that the difference is higher for the top and left electrodes. So you may guess that the finger is located closer to the top left corner. On the example web page, you can find more data calculated for different positions of the finger. And I will show you how to calculate this data. To calculate the data for different finger position, you should modify the geometry model. Open the geometry model, switch to the sketch view, zoom in, click to select the finger and move it to some other position. Build the mesh again, toggle to the three-dimensional view to make sure that everything is intact. Air, height, and this should be a finger. Yes, it is. And now you can again build the finite element mesh here and solve the problem again. If you search for the touchless sensor on our website, you will find the example page. Here you can read about problem setup, browse the solution section, take a look at the resulting pictures, and download the simulation files. Simulation files may be opened and the results may be viewed using any QuickField edition, including QuickField Student Edition that you can download from our website for free.